Welcome to Kannateri Institute of Chemistry. Today we will see the different laws of chemical combination. Laws of chemical combination are of 5 numbers. Number 1, law of conservation of mass. Number 2, law of definite proportions or law of constant composition. Number 3, law of multiple proportions. Number 4, Gay-Lussac's law of combining volumes. And number 6, Avogadro's law. Regarding my credentials, I have a PhD in chemistry from Kochu University of Science and Technology, MS in Quality Management from BITS Pilani, MSc in Pure Chemistry from Kerala University, and LLB from Mahatma Gandhi University. Regarding my professional experience, I have authored 10 chemistry textbooks. I have more than 40 years of teaching experience, etc., as given here. Now we will come to our topic, laws of chemical combination. As you know, law of chemical combination are of 5 numbers. Number 1, law of conservation of mass. Number 2, law of constant composition or law of definite proportions. Number 3, law of multiple proportions. Number 4, Gay-Lussac's law of combining volumes and Avogadro's law. First we will see the law of conservation of mass. This law was postulated by A. Lavoisier. It states that in a chemical reaction, the total mass of the products is equal to the total mass of the reactants. In other words, matter is neither created nor destroyed in a chemical reaction. The law of conservation of mass can be illustrated by taking the reaction between methane and oxygen to give carbon dioxide and water. In this particular reaction, you can see that 16 gram of methane reacts with 2 into 32 gram of oxygen to give 44 gram of carbon dioxide and 2 into 18 or 36 grams of water. The total reactant mass here is 80 gram. Similarly, the total product mass is also 80 gram. Or this reaction illustrates the law of conservation of mass. Now we will come to the law of definite proportions or the law of constant composition. This law was stated by Louis Proust. It states that a chemical compound always contains the same elements combined together in the same proportion by mass. For example, we can consider the formation of carbon dioxide. We can obtain carbon dioxide by different methods. By burning carbon, by heating limestone, by the action of dilute hydrochloric acid on marble, etc. But whatever be the way we prepare or we obtain our carbon dioxide, we can see that each sample of carbon dioxide obtained contains only carbon and oxygen, and that also combined in the same ratio of 3:8 by mass. Now we will come to the third law, law of multiple proportions. This law was proposed by John Dalton. It states that when two elements combine to form more than one compound, the masses of one of the elements which combine with a fixed mass of the other bear a simple whole number ratio. For example, we know that carbon and oxygen can form two compounds, namely carbon monoxide CO and carbon dioxide CO2. In both of these compounds, the amount of carbon is same, but the amount of oxygen becomes different. In carbon monoxide, we can see that 12 parts by mass of carbon combine with 16 parts by mass of oxygen. On the other hand, in carbon dioxide, we can see that 12 parts by mass of carbon combine with 32 parts by mass of oxygen to give carbon dioxide. Now you see the ratio of the masses of oxygen which combine with a fixed mass of carbon. Here it is 12 parts. You can see that the ratio is 16:32 or 1:2, which is a simple whole number ratio. So definitely we can say that the compounds carbon monoxide and carbon dioxide formed according to the law of multiple proportions, or they obey the law of multiple proportions. Now we will see a problem from this area, law of multiple proportions. The problem given is copper and oxygen combine to form two oxides which contain 88.7% and 79.7% of copper respectively. We have to show that these two oxides obey the law of multiple proportions. So first we will take the first oxide. We will assume that the quantity or the mass of the first oxide is 100 gram. Then we can say mass of copper in it is equal to 88.7 gram, or the mass of oxygen in it, therefore the mass of oxygen in it is equal to 100 minus 88.7, or it becomes 11.3 gram. From this we have to calculate, therefore, what is the mass of oxygen combining with 1 gram of copper. That you can get by dividing 11.3 by the mass of copper, that is 88.7. That 11.3 divided by 88.7 gives you the result 0.127 gram. Now we will go to the second oxide. We assume that the mass of the second oxide is also 100 gram. Then we can say that, or then we can write mass of copper in it is equal to 79.7 gram. Therefore, mass of oxygen in the second oxide is equal to 100 minus 79.7 is equal to 20.3 gram. From this we have to calculate, therefore, what is the mass of oxygen combining with 1 gram of copper in the second oxide. That we can get by dividing this 20.3 divided by 79.7 is equal to, you will get it as nearly 0.254 gram. So the masses of oxygen combining with 1 gram of copper in these two oxides is in the ratio 0.127 is to 0.254, or it becomes 1:2. This is a simple whole number ratio, and hence we can say that these two oxides are formed as per the law of multiple proportions, or they obey the law of multiple proportions. Now we will come to the fourth law, Gay-Lussac's law of combining volumes. This law is stated as, when gases react together, there is always a simple whole number ratio between the volumes of the reacting gases and that of the gaseous products, provided all volumes being measured under the same conditions of temperature and pressure. For example, consider the combination of 1 volume of hydrogen with 1 volume of chlorine to give us 2 volumes of hydrogen chloride. Equation wise we can write H2 plus Cl2 gives us 2 HCl. So the ratio of volumes of the various reactants and products here is 1:1:2. This is a simple whole number ratio. Now we will come to the last one, Avogadro's law. It states that equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules. For example, consider equal volumes of 3 gases, hydrogen, oxygen and nitrogen, contained in different flasks of the same capacity under similar conditions of temperature and pressure. Then we can find that all these flasks contain the same number of molecules irrespective of their nature, whether it is hydrogen, whether it is oxygen, whether it is nitrogen. It can be seen that all these flasks contain the same number of molecules. So this is what we know as Avogadro's law. Mathematically, Avogadro's law can be expressed as V proportionality sign N or V1 by N1 is equal to V2 by N2. V represents the volume and N represents the number of molecules. Do you find this video informative? If your answer is yes, please like, share and subscribe. Your support is really meaningful to me. Thanks a lot and see you next time with a new topic. A big thank you.